Okay, dear students, today we will see architecture of 8051 microcontroller. Now, architecture, what is architecture? Architecture will tell you how different circuit blocks are connected together and how do they communicate with each other inside the chip, inside the microcontroller. Now, don't get overwhelmed with the diagram. It's quite big, there are a number of blocks, but as we go ahead, as you understand how these blocks talk to each other, how these pins are connected to these blocks, you will be able to remember each and every block very clearly, believe me. So let us see architecture. Now you see this dotted line here. This dotted line indicates the chip. Okay, so whatever you see inside the dotted lines, this is there inside the chip, and whatever you see outside, like for example here there are pins which are shown outside, here there are pins which are shown outside, then here are a few pins there, and those pins actually come out of the chip. Okay, and using these pins you connect circuitry, external circuitry to the microcontroller. Now let us first make it very clear, like how many pins are there. There are 40 pins for 8051 IC. If you take, there are 40 pins. Now first of all you need to remember what are these 40 pins. You can easily remember these 40 pins. I'll just give you the trick, and then we will divide these blocks into different segments and we will study the interconnection. Now let us come back to the 40 pins. Now as you can see here, there are two pins, VCC and VSS. VCC is 5 volts, the supply that you give, positive DC supply that you give it to the microcontroller, depends upon microcontroller what is the supply that is needed, and then obviously the ground. So you require a ground signal and you require a VCC signal. So these are the two pins. Now here I have written 2. Then there are 4 pins over here. Now on my left hand side you see PSEN bar, then ALE, then EA bar and RST. These are the 4 pins. Now function of these 4 pins we have already seen. During my lecture I'll also tell you in one line what are the functions of these 4 pins. And there are, so these are the 4 pins over here, and then there are 2 pins which are used for connecting crystal to the 8051. Now you require an oscillator to run this microcontroller. You require a clock signal. This clock signal is generated by the oscillator, and you require a crystal to be connected from outside to this oscillator. So you require 2 pins there, XTAL1, XTAL2. So this 4 pins here, 2 pins here, 2 pins here, and then you require ports, right? So 8051 has got 4 ports. Port 0, port 1, port 2 and port 3. They are shown here, port 0, port 2, port 1 and port 3. So these 4 ports are 8-bit ports, or there are 8 IO lines connected to each port. So there are 32 pins required for that. So plus 32, so 4 plus 2 plus 2, 32 plus 32 is equal to 40. So we have seen these 40 pins. So it's very easy to remember these 40 pins. 32, so obviously you don't have any problem. Then these 2 VSS and VCC, you don't have any problem. Crystal also you can easily remember. Only thing that these 4 pins you need to remember properly, that is program store enable, then address latch enable, then external access EA bar and RST reset. These 4 pins you need to remember, so you remember all 40 pins. So that's it about the pins. Now let us go inside the microcontroller. Now this is 8051 architecture. So you see here that is this one is an internal bus. Okay, this one is an internal bus. And this internal bus is 8-bit bus, and this 8-bit bus takes signal from one particular block to another block. What is bus? It's a collection of you can say the collection of wires. We call it the bus carrying the same signal, same type of signal. It's called as a bus. So the job of this bus is to carry data from one block to another block. So as this is a main internal bus, it carries data from the latches, from ALU to other things, from memory to ALU, from RAM to ALU, ALU back to accumulator, and so on. So this is the main bus which is connected to all other blocks. Okay, you got that? Now let me divide this entire blocks into few categories. Now you see port 1, port 2, port 3, port 4, there are 4 ports. So let us call this as one category of blocks, ports, IO ports, right? So you have IO ports, Second, obviously when you talk about microcontroller, you require a memory, you require different types of memories inside. So second category of circuitry are memory, okay. Then the third category, let us see the third category. You see this timing and control circuit, obviously you require timing and control circuit for controlling different, giving out different control signals and the timing signals to the 8051. So we have IO ports, we have memory, then we have timing and control signals, then you have main processing unit, that is your ALU, I'll call it the processing unit, and then you have certain circuitries which are responsible for controlling the memory, that is ROM, the program that you store. So this is I can call this as this block which is responsible for doing that, addressing the memory, giving out the data of the memory from where you have to fetch address of the memory, from where you have to fetch data and all. So memory control, this is responsible for controlling memory. See, this is just for you to remember. There is no categorization as such when it comes to the actual Intel manual, but I'm just, in order for you to remember this properly, I'm just categorizing into these parts, okay. Now let us talk about IO ports. Now you have 4 IO ports, port 0, port 1, port 3, port 2 and port 3. Each IO ports have got 8 pins, IO pins. Now every port has got a latch, every port has got a driver, okay, because in order to drive external circuitry you require a driver. That means that microcontroller has to give out sufficient current, so you have a driver there, and then you have a latch. Now latch is used when you are going to output certain data, okay. So when you have to output certain data on any of the particular port, that data comes out from your accumulator, suppose, and then you write it on the port. Say for example, your instruction is move A comma P0, that is P0 is the port over here. So from accumulator you want to transfer data to the port 0, so it first goes out to the latch, and latch is the circuitry responsible for storing that value, and then that value is taken out to the port, okay. Now obviously every port will have a latch, and it also will have a buffer. Now what is the role of the buffer here? Role of the buffer is to raise or change the level of the signal, the strength of the signal. It will not change the strength, it will not change the data which is comes in, but it will change the level of the signal as per the requirement of the microcontroller, and that is the role of the buffer. So this is about the latch. 4 latches you draw accordingly first, and then you can show the drivers, and then you can show the pins. So this is understood. This 1 2 3 4 5 6 7 8 blocks are done. Then we will go to the memory section, okay. We'll go as per this only, then we'll go to the memory section. Now memory is of 2 types. It is RAM and ROM, okay. 128 byte of RAM is available in case of 8051, and 4K ROM, internal ROM, is available in case of 8051. So here the RAM is shown, and then the RAM, obviously to address RAM you require RAM address register, and to address ROM, you require program address register. ROM is also called as a program memory, right? You store a program in the ROM, so it's called as program memory as well. So program address register is responsible for addressing ROM, and RAM address register is responsible for addressing RAM. Okay. Now RAM is 128 byte. It is now we have already studied the structure of a RAM. It has got a register banks, 4 register banks. Then it has got a bit addressable memory area, and top of that we have got the scratchpad area. So it's 128 byte of RAM which is there, and then the 4K ROM. Okay. Now this RAM or ROM interacts with the other blocks through this data bus. Obviously data has to brought to the ALU through the ROM and through the RAM, so obviously there is a interconnection between the two. As if you see the arrows which I have shown, the data flow arrow, there is a bidirectional arrow which connects to the internal data bus through RAM, because RAM is random access memory. You can store the data, you can read the data, or you can write the data. But in case of ROM, it is not so. From ROM, you either store like when you write a program, you compile it, you convert it to hex, and you store it in a ROM. ROM, or you can have a 8051 version with a ROM or EPROM. Okay, electrically programmable read-only memory. Now, but the arrow you can see, there's only a single way. That means the microcontroller is going to read the data from the ROM, and it's not going to write it. Writing is done only once. When you actually compile and can get the hex code, that time you write it. So that is done only once, and when the execution goes on, that time the data from the ROM is read, not written. Okay. Now how this ROM is addressed to the, obviously through the program address registers. Okay. Now that is memory controlling. Now that is what I'm giving the word as a memory controlling, that unit. Now here the program address register is there, the RAM address register is there, and then you have something called as program counter. Program counter. Here you see the register. It's a program counter register. It's a 16-bit register which is pointing the address of the RAM. Address of the ROM. So it tells processor from where it has to bring the instruction to be executed. So in short, we call it as a program counter. We call it as in short, we say that a program counter keeps a track of the program. That means it is that register which is responsible to tell microcontroller from where the next instruction has to be fetched and executed. So here's a program counter. Obviously it should go on incrementing, so you require incrementing circuitry for that. It goes on incrementing. Accordingly, program address register then helps to access the ROM. Then you have a buffer, like we already have a discussion on the buffer circuitry. It is used for changing the signal level that we have seen. And then you have DPTR, data pointer. Now data pointer comes in picture when you are accessing external RAM or the ROM, external memory. Okay. For internal memory, you don't require data pointer, but data pointer is used for accessing external memory. This is again the 16-bit register which is divided into two. It has got lower byte, that is DPL, and it has got a higher byte called a DPH. So DPL and DPH are part of DPTR. So this is about this side circuitry. We have already seen the latches, we have already seen the memory part, then timing and control. Let us come to the timing and control circuitry. Now here you see timing and control circuitry, and this block is divided into two, timing and control and instruction register. Now see what happens, how does microcontroller communicates with the external memory or the ROMs to be precise. It takes when the microcontroller is powered on, at that time program counter is resetted to 0000. That means it will be accessing memory location 0000. From there, whatever instruction is written at that 0000 location is brought first to the instruction register, and then this goes to the instruction decoder, and that instruction is decoded. That means if the instruction is say move, whatever this opcode is there for the move is brought in, that is decoded, and after decoding microcontroller comes to know what is to be done, and accordingly control signals are generated. That is why instruction register is shown as a part of this block. Okay, and there is a timing and control signal to which oscillator is connected. Now oscillator circuitry is inside 8051, but externally you have to connect crystal to the oscillator circuitry. So there are two pins given, XTAL1, XTAL2. For connecting a crystal, obviously the two capacitors have to be connected for noise suppression and all, and then that is connected to the oscillator, and this oscillator gives clock signal to the timing and control, and accordingly using that clock signal as a reference, all the operations inside 8051 are carried out. Okay, now there are 4 pins which I showed earlier, which I talked about earlier: program, store, enable. Now this is a 1-pin program, store, enable. It is used for writing, at the time of writing something in the program memory. Okay, so enabling in order to enable that, we use program, store, enable. Then address latch enable, demultiplexing of address and data bus is done by address latch enable. Then external access, in order to connect use the external memory in order to tell microcontroller that yes, external memory is connected, and microcontroller has to refer to that external memory and not the internal memory. EA bar pin is used, and reset pin is obviously for resetting microcontroller. You need to connect a resetting circuitry to the microcontroller so that whenever power is on, there is a power on reset reset signal which is generated, and accordingly the default values of the resistors are loaded inside 8051, and then the function starts. Okay, now at the last we will come to the middle portion, which is actually the processing unit. The heart of the microcontroller is ALU, obviously is arithmetic and logical unit. The data to ALU comes from temporary resistor 1, temporary resistor 2, and then that data is processed and the answer goes back to the accumulator, obviously through this internal data bus. So accumulator gives one of the data to ALU, and obviously the other data comes from either the memory or any other register and so on, depending upon your program. Now there is one register here, 8-bit register, called as PSW. Now PSW stands for program status word. When the arithmetic or logical operation is carried out in the ALU, you require to know the status of that operation. That means, what do you mean by status of the operation? You need to know if the carry is generated, if the auxiliary carry is generated, if the parity is generated, and so on and so forth. So parity, auxiliary carry, whether there is an overflow, whether there is a carry generated, all these things are required to take proper decision, are required to be known by the programmer, and you go and refer to the PSW register for that purpose. Okay, now the accumulator is one of the main resistors of 8051. So it acts as the input to the ALU, and the answer goes on accumulating, again goes back to the accumulator, and that is precisely why it is called as accumulator. If you add a number 10 times, then after every addition, the answer will go back to the accumulator and goes on storing, or the 8051 will go on storing the answer to the accumulator. And then there is a B register here. This is denoted, accumulator is denoted by A, and B register is obviously denoted by B. So B register is used in multiplication and division operations, right? That is where the B register comes in picture. And obviously when you see the different programs related to multiplication division, you will understand the exact role of B register. For one time being, now you remember this B register is used for in addition, in multiplication and division operation. Then there is a stack pointer. Now remember, this is a part of a memory block. In fact, the stack pointer, along with the RAM and ROM, you should also remember the stack pointer. Now what is the stack memory? It's a part of a RAM taken aside for storing data temporarily, right? Okay, so there is no separate memory called as a stack memory. You have a RAM, you have a ROM, and stack memory is that part of the RAM which is taken out for storing data temporarily. You are going to decide where you want to store that data, any data. Obviously during the programming you will understand it better, but remember, any data that you want to store temporarily on the RAM, you have to use a stack for that purpose. There are some instructions like call instruction. That call instruction uses this stack memory of its own. It is hardwired into the execution of call instruction. Now stack pointer points to the stack memory, the top of the stack memory. Okay, so you see pointer. Now there is one more pointer, was there, data pointer. Now whenever you come across this word pointer, that means it is a register which is pointing to the memory. Remember this pointer word, that is very important. Like once you remember, once you understand the meaning of the words, meaning of the abbreviations or the meaning of the word, remembering the things becomes very simple. Now stack pointer will be pointing stack, top of the stack. By default it is 07. By default the value of stack pointer is 07, but if you use it, then it goes on incrementing, it goes on storing the data, and then when you take the data out from the stack memory, it goes on decrementing. The stack pointer is responsible for pointing to the RAM. Okay, it has nothing to do with the ROM, it has to do with the RAM only. So I guess everything is covered. You pay little attention to the arrows here which I have shown. This arrow is bidirectional. All these arrows are bidirectional, connected to the port. It is because ports are input output ports. They are bidirectional port. Data is stored inside and data is taken out. Both the things are done. So these are bidirectional ports, right? And this bus here that goes like it accesses ROM. Then the ROM data is taken out, and then also it is connected to the port also, because obviously the data it has to be internally. These ports also need to be connected internally to the bus and other blocks. And only the last thing I'll mention, these port pins, they are not a single function, they are multifunction. That means along with input and output operations, there are other functions attached, given, assigned to these pins. Like port 0 and port 2. These two ports, along with IO operations, they carry out, in fact, the address and data. Their address and data pins are also there. Like 80 to 87, that is your port 0, and then higher order address is taken care by port 2. Then port 3 has got, each pin has got multiple functions, like timer 0 है, timer 1 का ये है, interrupt के signals है. So ये सारी चीज़ें जो है port 3 को assign की गई है. Port 1 अकेला ऐसा port है जिसको कोई alternate function assign नहीं किया गया है. So obviously this is just the architecture, but every block needs a explanation, and with the help of the programs when you write, if you try to imagine what must be happening inside the microcontroller, then you understand this block better. Just this block which I forgot to cover, that is SFRs and timers, because that is connected to port 3. As you can see, port 3 has got the pins which are actually taking care of say timer operation and the interrupts. So obviously SFRs, that means special function registers, which is a part of RAM, and the timers are shown connected there. Now SFR, special function registers, there are certain registers which are user programmable and the user can use it, general purpose registers, and there are certain registers which are special purpose, used for some special purposes, like say accumulator is a special purpose register, you have B register as a special purpose register, then this latches, port latches, port 0, port 1, port 2, port 3, they are considered as special function registers. Then for controlling timers, you require special function registers such as timer mode control registers, timer control register, and then you have different interrupt circuitries. For that also you require special function registers. So all these special function registers are shown as a one block in the architecture. Okay, you can draw in detail or you can show it simply like this, and can explain in the explanation, you can explain what are different special function registers as well. So that is shown as a port 3, because mainly the port 3 is responsible, all these different pins, if you see the interrupt, okay, connected with this, then the timers are connected with this blocks and all that stuff. and SFRs are also connected to the, obviously, to the internal data bus. So that is it about internal architecture of 8051. Don't get overwhelmed with the number of blocks. If you understand how exactly the blocks function and what are different features of 8051, then if you categorize the block into different segments like this and remember the functioning of the microcontroller, you will be easily able to remember all these blocks. Okay, just remember the features and based on which you remember these blocks. Once or twice if you practice, you'll be able to draw this program, the entire architecture, if it is asked in the exam. Okay, so thank you so much. We will definitely see the entire programming, and during the programming we will see how these blocks interact and from where does the data comes out, who is responsible for data and everything, and then obviously the ports, detail about the ports also will be studying in detail. Thank you so much.